as we all know, there is this siren song of AI. Everyone wants to be doing AI, and for various reasons, they will make the investments and they will charge their teams with delivering AI-driven solutions. I myself have worked for a couple of different companies where literally reporting to the CEO will pull me into the office and ask me, all right, what are we going to do about AI? How is it going to be meaningful? What am I going to tell my investors? What am I going to tell my board? What kind of press releases and other marketing can we make out of it? What is the overall AI strategy? And what are we going to do? So there is for all these reasons, heavy investment in AI, and often driven by very recent and exciting advances in very sophisticated modeling approaches, sophisticated technologies. But today, to kind of launch this, I really wanted to ask this, or put it in a sort of framework of, what are we going to use the AI for? How is it helping us? What is the question that we need to be asked? Besides the effect of, are we, none of us, I think, as technologists, none of us are interested in an AI rubber stamp. Like, yep, we AI'd that, almost like Google became a verb. I think AI is now starting to become a verb. I think really, again, I'm just passionate about the fact that like there has to be some actual value to the business for it. And if there's not, then we're just doing it for all the wrong reasons. So that's what I'm going to talk about. So there's a lot of focus on complexity and deployment and scale and what's my what's my stack and but I think we often kind of forget that first we just have to talk about the value. What is the value? And this word is going to come up over and over and over again about the value. The business value, fine, there may be value from a PR perspective, but really at the end of the day, like, let's put some actual dollars and cents to it. So, and let's talk about having measurable outcomes. And we'll talk a fair amount about this. Talk about not just technical metrics about accuracy or area under the curve or F1 value or any of these kind of esoteric technical concepts of machine learning or AI performance, and actually talk about how is this going to improve our actual value to the business, the return on our investment. So how do we measure that, or at least not even measure it? Before we even measure it, can we just set it up? Can we just, as a business unit, set up the ROI conversation, talk about how we're going to do that, and then say, all right, if we do that, can we justify investment? Can we justify additional investment? Can we take a 1-month investment, make a measurement, and then say, okay, there is some return. What could that return be if we made additional investments in time, in data, in technology choices that we have at our choice? And I'll talk about, as a part of this, my belief in that before doing anything else, we need some really simple baselines to understand where we are and where we need to go next. So the very first question for any set of business leaders is to talk about, what is it that we're really looking for the AI to do? Is it about cost? Because we're going to somehow have greater automation or reduce some source of errors that's going to reduce our cost of doing business on a day-to-day basis. Is it about growth? Is that we're going to reach customers in a better way or keep customers in a better way? Is it about efficiency? Are we going to do the same thing we're already doing, but we're going to do it faster, or we're going to scale in some other way? Or is it about customer experience, that there's going to be greater stickiness to our product because of how the AI brings them in? Again, it's not about accuracy. It's about what's the problem that we're trying to solve, and having a really clear upfront, before anyone starts writing code. I'd even argue before anyone starts hiring any AI machine learning engineers and AI data architects, what is it, the problem that we're trying to solve? What is it that we want them to come here and do? And will we know that they've done it? what is the definition of success for that team? Not just through, starting with and including KPIs, but what are the downstream metrics of performance and metrics that we will know what success looks like? So, just a quick review. When we talk about ROI, I think people throw around this term, but let's just remind ourselves, there's some total cost of ownership. There's the cost it's going to, most people think about like, yeah, great, I got to hire a person or hire some team. I have to pay that person or that team. I'm going to, invest in, or even company. Maybe we outsource our AI development. All these things are possible. There's the team, there's the data, there's the infrastructure we need to set up and to support over time. There's the deployment. We need to continue to monitor it. All of that is part of that total cost of ownership calculation, which, like any TCO calculation, can, in the first part, is arguable. Different people will come up with different numbers, but it's part of the conversation to have, right? And that's really, the overall arching idea of this talk, this lightning talk, is to get people kind of talking about the devil in the details. So understanding what that total cost of ownership is, what is it going to cost to embark on some particular AI adventure? And then, of course, the flip side, what are the benefits? What are those metrics that we hope to improve? And when we improve those metrics, what is the expected financial gain out of that particular metric? Let's actually know that first and foremost as the tangible side. And then, of course, there are the intangibles. There's, of course, we want to be an AI company, because if we're not an AI company, then what does that mean to our morale and our company retention and our investors and everything else? What does it mean to our brand? And is there risks? Are we going to be outcompeted by our competitors because we have not invested in AI? So, again, the overall ROI then is the difference between these two, then scaled by those costs and multiplied as a percentage. A key aspect to this thing is that an ROI calculation is not a one-time activity. It's something that should be continuously reevaluated, because every single part of this equation, from the data and the infrastructure and the deployment, changes over time. Maybe it makes a lot of sense last year. Maybe it makes a lot of sense this year. Maybe next year it actually doesn't make so much sense. So, this is not just a one-time exercise and a one-time budget justification, but I think as a leadership team, it's a continuous budget justification. We justified it last quarter, and we're going to justify it this quarter, and we're going to justify it next quarter again, because here's how those things have changed. What I also encourage people to do is many executive teams like thinking about it this way, not so much about ROI, but it's about NPV, net present value. If we're saying we're going to invest in this particular team and this particular set of elements, be that data and infrastructure and everything else, okay, we could take that money and we could do something else. We could buy more NMR machines if you're a small small drug developer. There's some particular other technology investments that could be made that could be spot on to your particular business value. I think we should compare those and say, like, if we really are going to understand and strongly invest in our AI opportunities, we should understand that we actually considered alternatives, and we still believe that this was our best route to value. So now I'm going to kind of switch gears and talk about really, the thing that I'm hoping that you take away from this talk there, that may be a little bit new to you, is thinking more in a more nuanced way about not just AI machine learning, but errors. We tend to focus on the accuracy and when the machine makes things faster and comes up with a good answer and allows us to do things. But what about when it's wrong? So again, I've said this, but the technical metrics that we talk about, the accuracy, the percent positive value, the percent negative predictive value, F1s, areas on the curve, ROC curves, they're useful from a technical perspective to compare different algorithms, but from a kind of executive leadership team trying to understand the value to the business, those numbers don't have direct relationships. What I found in my own experience is that if we instead take those numbers, take those sort of F1s and whatnot, and translate them into a value proposition, or on the flipping that around, a cost proposition. When we make mistakes, which by the way, we're making mistakes anyway, and the point of the machine learning or the AI is to improve upon those mistakes. What is the cost of those particular errors? What is the cost now, and what is the cost in the future? What could that be? So the false positives. What's the problem when the AI says yes when the truth is no? This is, I think, from a generative AI. People would call this hallucination, right? When the machine hallucinates a particular answer that is not the truth, then what is the cost of that? How does that impact us? And by cost here, we're really looking for a dollar amount. What would this lead to? What red herring false amount of work will be generated based on a false positive? A little bit harder are the false negatives. What happens when the machine says, no, that's not a good drug target. No, that's not a good drug molecule. No, that's not a good patient that could respond to your therapy. These are lost opportunities, right? These are missed opportunities that can be a little bit harder to quantify exactly, but are still worth a conversation to come up with a number. So digging in a little bit more about costs is that most machine learning algorithms and AI algorithms come in with a default assumption that the cost or the error associated with a false positive is of the same magnitude, has the same value as the cost of a false negative, that the two are sort of equally a problem. And when you then go to train your algorithms, the so-called cost matrix is symmetric. You're trying to minimize both sets of errors. And of course, in different contexts, and for the interest of time, I won't go through a whole bunch of examples, but in different contexts, those could have very different costs. And so in the real world, the costs are asymmetric. And really the main message here is have that conversation about, for the particular use case that you're trying to apply AI towards, what does that false positive or false negative really drive you to? If you're the Spotify or Pandora algorithm trying to predict what's the next song my listener is going to like, the false positive maybe not that much of a problem as long as it's somewhat limited, but you still want to bring in things. You don't want to miss all of the new music that your listener might like to hear of. So the answer is, define those costs, starting conceptually, but then later try to put real dollar amounts. What's going to happen to my Pandora listener that is never really hearing any new music that they might like to see and gets bored of the service and now is gone, versus some other user that is liking the new music they're hearing, but they're also hearing lots of random things that they never wanted to hear? What is that cost to our service, and understanding how those metrics might convert into dollars. Once you have that, you can use a tool that I think most practitioners or many practitioners have never run into before, which is something called the cost curve. And so the way this works on the left is you have a normalized cost, right? And this is mathematically normalized just to range between 0 and 1, but you could also have real dollar amounts here for your purposes. And then the idea is, along the x-axis here, you also have this normalized, essentially, probability of an event being true or false. And once you set up this as your axis, you then have lines that go here that represent particular, I would say, default algorithms. So here we have at the top 4 very dumb algorithms. The one at the top is the algorithm that is always wrong. It will always, if it's a positive example, it will say negative. It's a negative example, it will say positive. it always has the worst cost no matter what. And so it's at the top. So that's the one end of the extreme. The other end of the extreme is the always right classifier, or the always right method, that no matter the sort of prevalence or the changing in possible costs, it is always right, and so it always has the lowest expected cost, which is 0. Then we have these two other, what I call dumb classifiers or dumb methods, that conceptually is always saying yes or always saying no. And, depending on the relative prevalence of the relative situation, either has maximum cost at one end and minimum cost at the other end, or vice versa. This sets you some boundaries that says, like, well, if I have an algorithm, just to use the Pandora example again, if I have an algorithm that predicts the next song that someone should like, but the probability of someone liking the next song is actually very, very low, then I need to be, somewhere above this line to be able to come up. Sorry, I said that wrong. I need to be below this line. You would always want to be below this line in this gray space, which is essentially the zone of opportunity. And any given classifier that has some particular false positive and some particular false negative rate, which on an ROC curve would just be a single dot, right? A single dot with one sensitivity and one specificity value. In these curves now becomes a line. So you see here 1, 2, 3, 4, 5 different lines. Each of those 5 lines represents one particular classifier with one particular sensitivity, specificity, characteristic to it. And what they describe then on the cost curve space is this line that, together they then generate a manifold, if you will, a sort of set of opportunities where together, depending on what the overall probability of experiencing a particular cost, each of them has the lowest cost in some particular domain. So here, at the lowest probability of experiencing a cost, this particular classifier, the first one, has the lowest cost. But over here, at higher probability, because of its false positive, false negative characteristics, it actually has the highest cost between all of them. So again, the overall point here is to have some understanding about what is the possible false positive and false negative rates for your particular method going to do in a real world situation where you may know that your probability of errors falls within a particular range, and this gives you a way to actually evaluate particular models in a way that the kind of more sort of technical ROC does not. And I left the link to a good article, a good review article, to understand that. So lastly, then, in this really quick lightning talk, I'm just going to talk about, again, what is very, I'm quite passionate about, and what I force my team to do sometimes, in which they do sometimes begrudgingly, is talk about a baseline. And it starts with, what is it that we could do really simply, like literally within an hour or two? What is the simplest linear regression or logistic regression? What is the, or even a sort of heuristic, like, just a human-based, sort of decision tree, if this, then that. Let's just build that just to start with, and then let's put it through all of our various metrics and tests and understanding of, does that simple baseline, how far away is it from wherever we set the goalpost? In fact, many times I find probably about 25% of the time, that simple method actually is already through the goalpost. It already meets the stated goal of what the business had in terms of what the level of sort of improvement is that they're looking for. Of course, that's really exciting. Then the business says, great, let's do even more. And there's additional investment, but it gets us into that conversation. It's a starting point for that conversation about, where are we at? Where's our starting point? Where do we need to go to next? Or where could we go to next? Firm believer in having that proof of concept and updating that proof of concept and constantly having, okay, this is the new baseline. This is the new baseline. At every improvement, at every iteration, we're coming back by saying, is there additional investment that will now warrant beating whatever our current method is? But I also say, it's not on the slide, but just as a quick tangent, in a product development standpoint, where yes, the model is important, but there's the model, and then there's everything else. There's all the user interface and all the process. Having something simple as the starting model means that you can also then focus on all of those other things. Your user interface and user interactions, your design elements, your customer support, everything else that actually doesn't really matter what the model is, or as the model gets better, it can only get easier. You can start that in parallel or continue that in parallel once you have proof of concepts. So again, I think I've already said this, at each step, then you can justify the additional or re-justify the additional investment, or turn around and say, you know what, this is good enough. We can move on from this, or we can take our dollars from an NPV perspective and put them somewhere else. So that's what I wanted to say. I know I've gone through it really quickly in the true sense of a lightning talk. I want for me to talk less and people and to turn the conversation back to everyone else. But again, focusing on quantifiable ROI, something that is in the business language, in the domain that these models are actually trying to solve. Understanding better the idea of what are the particular errors that the models can make and what is the cost of those errors. We focus very much on the benefit of the accurate predictions. What is the cost that we have to then suffer when our models make these errors? Use baselines to both understand where you are and where you could go next, and justify that and re-justify additional complexity, additional effort before you get to the complexity. And again, as head of AI for a couple of different companies now, at the end of the day, what my CEO is looking for is not a whole bunch of code. What they're looking for is value. They're looking for outcomes that code enables. And I'll stop there.
Great. Well, Aaron, thank you. That was a lot to unpack, and I'm sure it gave everyone food for thought. I just want to make sure I give other people opportunity to ask questions, then I have a few. So is anyone, I guess Ali has raised his hand. Ali, do you want to go ahead?
Yeah, actually, I was just clapping, but
Oh, okay. Sorry. Sorry,
Aaron,
I misread your reaction.
No, it's all right. Now that I am on, now that I have the mic, so thank you, Aaron, for a very insightful talk. It actually gives me, so how I read it is we ran into a couple of problems that we took decisions on, and going through this talk, this actually gives me that expression and that ability to explain why those decisions were necessary and how those decisions were taken, instead of me going through the longer path of, okay, this makes sense, let's do this. Now I have a better way of explaining that through especially that curve graph. So thank you very much. This was very, very insightful.
Great. Yeah, the whole cost curve thing is, I mean, it's been around for a while. I mean, I first saw it in 2000 or so, and then at a KDD conference, and then 2006 there was another paper on it. That's actually the one that I linked to. So it's been around for a good 20 some years, and those who know about it, but most in the field haven't seen it before. There is this sort of prevalence of the ROC curve and the precision recall curve. Again, those curves are very useful to technologists to understand what's happening with their different models over different scales. But from a sort of, and again, maybe this is my kind of bias, I spend probably half my time with my technology teams and the other half my time with executive leadership teams, trying to help them to understand what are our opportunities. Where is, great, we have this AI vision and we have these strategies, but what is it really going to do? And I think having your having your CEO and having your your board of directors actually having a more sort of tangible understanding of like, oh, this is where we are. We're here on this cost curve, but we could be here on this cost curve. And when those cost curve numbers have actually, axes have actual dollar amounts on them, is a very very useful visual.
Thank you.
Aaron, do you find you have to describe this any differently than any other big feature build? I mean, at the end of the day, what you're describing, I could apply to anything. AI
Generic.
might feel like a bit more of a black box, but it's really properly justifying a feature, right? Or a platform change, maybe it's bigger than a single feature, but
So if by feature you mean like, oh, we could turn this button into something else, and some
yeah, so
users.
I'm coming from a software perspective. So
Yeah.
for me, feature would be major. I think the comparison here would be we're adding a new piece of functionality. How we build it matters less than what that functionality delivers, either to us or to the customer, right? And so what's interesting to me is everything you went through, it's similar to some of the things I've done, but we get so caught up in AI. Is this not just NPV, TCO, pick your structure
No, that's true.
of a new big project build?
Yep. So I think that's true with the wrinkle. I guess the one wrinkle here in the machine learning AI space is that we are talking about making predictions. We're talking about investing in some underlying technology, that a model, to use the word very loosely, that's going to be a black box to the user, that's going to help them to do something in a way that without the black box, they would do differently. And so what is the differences of what it's asking them to do?
So what you're saying is the difference here is instead of a definitive feature that we build it, it does a thing. And I'm using feature loosely. It could be a new product. You're saying we build a thing that usually under a curve does a thing, and that the probability outcome will be beneficial. And so it's the probabilistic piece that's the addition to something, at least in the software world, normally built around certainty, although we've all used software that didn't do what people said it should do.
Yeah, I mean, I love to pick on, I have a couple of different software products that I pick on, TurboTax and Photoshop. But let me use Photoshop as my sort of favorite example. Like, the product team on Photoshop at some point has to say, like, we've got a lot of complexity in our tool. Let's add one more shiny widget. And I think there is, so I'm trying to be kind of, responsive to your point. There's a decision about, do we invest in that? Is it going to have value? What's the net positive value of adding just that much more complexity? But the point is, the new super lasso is going to do something new that the previous dumb lasso did not do. But the difference here is, what if the super lasso sometimes did what you wanted it to do, was supposed to do, and sometimes didn't? Right. That's I think the kind of nuance here is that the it's not just a feature that we can describe and say there's some user acceptance criteria that means the thing is well defined. It's that the thing is well defined, except that sometimes you get the thing and sometimes you don't.
Okay.
And what is the problem? That's the kind of, it's this sort of hyper focus on, yes, there's a value to a user to be able to to do that new thing, but what is the cost to the user when they try to use it and now get frustrated?
Yeah, so to your 2 points, if the lasso doesn't work as expected, it's frustrating unless you're a professional graphic designer, maybe not costing you money. If TurboTax makes a mistake, it's still on you. The IRS still blames you. You can point to the software, but it's on you. That's a big, expensive mistake.
So it's a great example where when the TurboTax people talk about AI, they're not, they're going to use AI for certain things, but they're not going to use AI to come up with the numbers to put into your form.
Yeah.
Yeah.
Thanks.
Yeah.
Anyway.
Because I mean, because of just that. I mean, just going, because the cost of making a mistake is so high to the user, and then of course that would then be of cost of so high to Intuit, to their brand.
Yeah, and that's why for us it's easy because we actually do the system in your car that recommends what song to play next for radio. And unless you're playing country and it suggests urban rap, if it gets the wrong country artist, no harm, no foul, right? As long as it
And as long
doesn't
as
do that
it's
too often.
yeah, and that's why you are probably using adaptive reinforcement type systems where you can make a mistake a couple times, and when the user hits the thumbs down button, you can learn from it.
Yeah. Yeah, but the cost of the mistake is not high.
Is low, right?
Aaron, and for you too, David, I have a question around the launch philosophy. So like with, measuring, obviously you have a philosophy for how to improve your product, or model. But there's trust, there's reputational risk, there are all those kind of things that happen before you launch something, right? So how do you connect this to like, how teams should launch and what they should think about? In some cases, the baseline is not like the previous AI solution, it's like a human delivering the same value. So like, how does that in your mind work?
So we have products where the baseline is a human. And so you're looking at accuracy versus cost and speed, right? And we are looking at mistakes. With every product team, I don't have something as nicely structured as Aaron, but I do fundamentally ask people, if this gives you the wrong answer, what happens? As a product owner, does that bother you if it gives you a wrong answer 20% of the time, 10%? And when you say 20%, immediately most people freak out. But then you might realize for a certain use case, 20% is fine, right? It forces product people to actually think it through. So I think an interesting offshoot of this, and Aaron, I don't know if you've seen this, is very rarely have product people actually thought through what acceptable error is. Certainly in the realm of software features. In science and research, it's a well-measured thing. But so from a launch perspective, I don't know if it changes anything from launch. It very much changes test, right? I come from a company where the signal processing stuff was all bit accurate testing. Well, bit accurate, that went out the window, right? So what was our acceptance criteria? It will be correct 80% of the time. Can you test in a way and land at 80%? So, and then I haven't gone through this yet, but talking through reminds me, I need to make sure the product people are telling the marketing people it's going to be 80% because you have to adjust your messaging to set consumer, in my case, consumer expectation of 80%, right? Because marketing people have a tendency to go, always knows you, always right. They like big absolutes, right? Because they're marketing people. And so how can you soften, talk about, understands how you're usually feeling, or right? It's just a subtle word change. So I would say QA and messaging, but the upfront piece, kind of going back to Aaron's structure of what is acceptable error and what would be the cost? How would you handle it if in a message board people start saying this is wrong reasonably often? Do you have a strategy for that? Did you think that through? Will that bother you? Will the CEO send you a copy of that post going, WTF? Right? We could look to Sonos as it took out the CEO and the head of product. It wasn't AI. It was just bad release with bad expectation setting. But it took out the CEO and the CPO of a software company. So I guess those would be my things. But again, consumer software or B2B to C software.
Okay.
I will add on, a lot of our projects right now are the infrastructure used to provide our software, not direct features. We have some direct features, but a lot of it is like the metadata and stuff behind it, where it's replacing people, doing really boring. Does that look right? Yes.
So I would say even those internal, I think of as the sort of the internal tool stack, where we are both the producers of that tool and also the consumers of that tool. And so all we have to satisfy is ourselves. We're trying to satisfy our future selves, our future selves who get to use the tool, or in the case of sort of some automation, kind of forget that it's even there, right? I mean, that's the nirvana, that CI/CD tool stack or whatever it is, that it's so much like plumbing or wiring that we just don't even think about that it's there 99% of the time. But that's the sort of tooling that in my world, drug developers, drug discoverers are using a tool to say, is this the molecule that I should go synthesize? And by the way, it's going to take a week to synthesize it. And then it's going to come in, we're going to order it, because it's going to be synthesized externally, and it's going to come in, and then we're going to do some round of testing with it. And that's going to take, a few days. That's the cost. That's the cost of the sort of yes or no, to that particular, to making a decision about that molecule. And when it works, back to your sort of 80% of, or if 80% of the time it's a good molecule and 20% of the time it's not, like, is that sufficient? Like, are we okay with that? And it's really not a yes or no, but 80%, it's relative to what, relative to what
is that better than what you were getting before?
Exactly. So if right now we're only getting 50% based on, humans scribbling on whiteboards, then 80% sounds great. Yeah. So I saw a question.
Yeah.
Naman, go ahead.
Yep. Thank you, Aaron. This was like really insightful. One perspective that I'm looking at it coming from product and engineering background. So I feel like this has an implication on the way product teams are structured as well, because the traditional way where you have product team, they are working with customers, trying to figure out best customer experience and things like that, and they're doing all that experimentation with customers. And then you have engineering team. Even if the product team understands that, oh, these are the measures, this is the cost of errors, and like these are the things we need to look at when like measuring outcome. The problem sometimes is also how well is that understood, like by the engineers or the scientists working on the team. Like, do they understand that component as well or not? And then sometimes, let's say, product team is doing some customer experience testing and trying to figure out, oh, feature 1 looks better or feature 2 looks better. And especially like these days with a lot of AI tools, if the engineering team is like, sometimes the engineering team wants to test something, and like, now do they wait for understanding of the feature coming from different customer testing and stuff? Because a lot of these different teams, sometimes they get out of sync in terms of pace and stuff. So this to me seems like, oh, you need better, like you need to structure your teams in a more cohesive way, where it's not that, oh, product engineer understands some cost of some error, but maybe the quality assurance team doesn't, and then they are doing testing, and that like then it becomes a cyclical thing that engineering team does the job, and then product team measures what's the outcome of it, and then they go back to engineering. So that cyclic process that is often followed, that seems like a big like sunk cost and like big problem in this kind of setting. So any
Yeah.
such teams where you have seen such issues, or like how people solve these?
So I think what you're bringing up, let me kind of translate that a little bit. What you think you're bringing up is sometimes it's very hard a priori to describe exactly what the cost is going to be of the mistake. And sometimes teams end up iteratively exploring it through by taking prototypes or new products and actually putting them in the hands of customers, and then just kind of finding out. And especially in the kind of a sort of A/B testing mode, you can be like, okay, here, A is our current product and B is our, new version with that new model that does this new stuff. And now how are users experiencing that? What is their, and again, your metrics that matter to you, whether that's time spent in app or click-through rates, or whatever those KPIs that you care about, that you can start saying, well, A, have we seen the improvement that we thought we would, yes or no? And B, when things seem to go wrong, because they'll go wrong either side, can we now trace those events too and see is there some repercussion of it? And is the repercussion the same, or is the repercussion actually worse than it was before? Oh my God, they actually uninstalled that whole operating system because they just couldn't handle it anymore. So, I think that is part of the reality too. My talk obviously set it up in a somewhat idealistic utopian world where you can in advance describe all possible costs of ownership and all possible benefits and all possible costs and come up with and make, as a decision framework. That's an ideal. I think the real world or the reality of it is, no, it's more of an evolving situation, but at least having that framework in mind so that you can say, okay, we are going to go into this A/B testing framework. We do have some new customer experiences to try out, but let's also measure, let's also pay attention, not just to the benefit that we expect to see, but what are the costs that we are then incurring as well. And even if we didn't know what they were in advance, to at least have them, on the page to be measured, to be accounted for.
Hey, thank you very much, Aaron, for that. And I think, guys, just looking at the time, we probably should wrap up at this point. This was a really wonderful discussion. Thank you, everyone, for participating, and thanks especially, Aaron, for the great discussion, for leading it and sharing those notes. So we're planning to continue with this series with more practical, real-world conversations around AI. If you're working on anything interesting or know someone who is, please reach out. We'd love to hear from you. Invite them for our next talk. And also please share feedback. This is our first one, so I'm sure we did a lot of things wrong, and I'd love to improve that for next time. The talk was very engaging and interesting, and I'm sure there are many follow-ups from that too. So share who's sort of helping coordinate. We'll try to share the reporting, and if you have any sort of questions or any suggestions, please reach out and let them know. With that, thank you, everybody, and see you next time.